So what happens to these loci of triangle centers of cevians with respect to a rotating family of equilaterals as P is no longer on the circumcircle of the family, but it is at some intermediate distance from the center of the family. So for example, let's go ahead and make this distance be larger than the radius of the circumradius. Now something interesting is happening here, okay? Exactly when P is on the circumradius, the locus is a straight line we saw before. Remember that when P was in the inner, the locus was an ellipse. This locus was an ellipse, right? Now let's go back to the outer location, where the locus is a straight line. And as soon as we perturb P away from the circumcircle, x2 undergoes a sudden transformation, but it's a pleasing one. So let's go ahead and nudge P out of the circumcircle. It's at 1, let's go to 1.01. Now all of a sudden, another branch of a hyperbola appears. Okay? So when we were actually previously saying that x2 was a straight line in this position here, right, when P is exactly on the circumcircle, what's actually happening is that there's another parallel branch. This is actually a degenerate hyperbola, where the other branch is actually tangent to the incircle. And how do I know this? Because as soon as I perturb x2 away from, say, the circumradius of exactly 1, it's now at 1.01, so I have like a slight nudge of P away from the circumcircle. This other part of the locus has materialized itself. So what this means is that over the triangle family, x2 had been actually virtually passing through this other branch here, but at infinite speed. So the software cannot draw a locus of the second branch, cannot sweep the second branch, because x2 had been passing through it at infinite speed. So it was never actually passing through it. It was virtually on it. So it's a virtual second branch of a degenerate hyperbola, which is two straight parallel lines. But now when we nudge this away, this branch reappears, and now x2 is passing through this, albeit at very fast speed, at a finite speed, so the software can actually draw it. And if I actually nudge this further out, to say 1.05, where 1 is the circumradius, now you can see that a phenomenon is starting to become more clear. And I'm saying that this guy is a conic, which is obviously a hyperbola. So interestingly, the locus of x2 when P is outside of the circumcircle is a hyperbola with major semi-axis obviously along the center, the line from the center of the system to P. So this is a hyperbola. What happens if I apply an affine transformation? I remain a hyperbola. Again, all the constructions here are projectively invariant, so x2 is going to remain a hyperbola. So it will be sufficient for us to prove that in this general setting, the locus of x2 is a hyperbola, with the degenerate situation of it being a let me do what I was doing before. Let's nudge this back in. Of it being a degenerate two parallel line hyperbola when P is exactly on top of the circumcircle. You can see here that I'm really approaching that situation. And then when P is exactly on that circumcircle, one of the branches, which is virtually tangent to the incircle, disappears, and I only see the other branch, which is now perfectly straight. Now, what happens if I now come inward, right? Let's go inside. Oops, check this out. x2 has become a beautiful ellipse. It's become a beautiful ellipse as P is approaching the incircle. And doesn't look like I'm a circle. Okay, x2 is not becoming a circle. It's actually going towards that other phenomenon we saw when P is exactly in the inner ellipse. x2 is an ellipse tangent to the incircle at P with one of the semi-axes equal to the circumradius big R divided by 10. So this is the situation we saw in the previous video regarding x2 of the cevian. How about if I actually now enter the incircle? what happens? I continue to be an ellipse, an ever small ellipse. You can see here that although I'm approaching a circle, it's never going to be a circle. In fact, this guy is going to be an ellipse all the way to when P actually goes to the center of the system, in which case x2 actually converges to a point. So this is an interesting situation. So I'm ellipse, ellipse, ellipse. When P leaves the circumcircle, then this ellipse at the transition becomes a very degenerate ellipse, meaning it's so long that its two sides look like parallel lines. On the circumcircle itself, it is two parallel lines, right? And so much so that I can only see the outer one. And then outside of the circumcircle, I'm actually a hyperbola. So this is the story behind the conic loci of x2, which are invariant over affine and probably projective transformations. How about x3? We know that x3 did not look nice, right, when we actually placed P in the incircle, so likely it's not going to behave well here as well. Here's x3, it's a straight line. When P is on the outer, on the circumcircle, it is a nondescript, let's see if I can do that. Where is it? Yeah, so, no, actually x3 was a parabola without the affine transformation when P is on the circumcircle. So we thought that this was a parabola. And now if I actually, so I went from a straight line on the outside to a parabola here. Let's now go ahead and nudge. Let's go back to the outer. x3 was a straight line. And let's nudge P outwards. Like that. So as soon as I nudge P outwards, I'm getting that x3 has become something that looks like a four-branched curve. So this is not going to be interesting. How about if I move backwards and I now go to the interior of the circumcircle? Over here, it looks like, yeah, x3 is again a very complicated curve. Not interesting, right? So if I go back to the exterior here, I go through a transition, but then it doesn't look like I'm going to remain a straight line or a conic anywhere as this guy's moving inward. Let's see if there's a transition when I'm actually now in the interior of the incircle. So I'm claiming that this guy here could be a parabola, and then when I go to the interior of the incircle, it could well be that this thing now is, well, it's actually not being flagged as an ellipse, so I would actually doubt that this thing is a conic, but it looks very much, right, like an ellipse. Let's move the triangle around a little bit, or let's move P around to see if I can ever flag this thing as being an ellipse. It doesn't look like this is an ellipse at all. So it remains to be proved or even numerically verified that when P is exactly equal, P is exactly on the incircle, this shape is, after all, a conic. It might not be. It might be part of that family, but it looks like it could. The ovals could actually go through singularity here and become a parabola exactly in this situation. Okay, how about x4? So x4, we were calling this thing potentially a conic. Previously, what happens as I move into my incircle? Let's go back to P being on the incircle, and now let's make this thing be variable, and let's move inside of the incircle. Again, this looks like a family of ovals that is not being flagged as an ellipse at all, and it doesn't look like an ellipse. So as I move outside, what does it look like? This is starting to look like a hyperbola, and we do know that x4, yeah, oh, that's quite interesting as a phenomenon, because we know that when P is on the circumcircle, and let me move P over here, x4 is going to degenerate to a point. So it looks like the degeneracy is actually happening in a geometrically interesting way. There's kind of a cusp, or something that looks like a cusp approaching the center. And let's go one nudge forward, one more. And it looks like that other branch, let's go back one step. There was another branch of the curve here, which is very degenerate, and I'm not numerically computing it very well. There's not enough resolution for it, but it looks like this branch is going to disappear or go toward infinity, become further out. And this branch here is going to collapse in a very interesting way to a single point. So let's see how this thing is going to be doing it. Ignore these straight lines, which are just artifacts. But yeah, it looks like this curve now is going to collapse. So when I get to 1, this thing collapses to a point. So, and then as I move outside of my circumcircle, I get now a curve that seems to have several branches, and it does not look particularly amenable to analysis, so we might as well ignore that. Let's take a look at what's happening to those other points that produce some neat results, such as x13, the Fermat and isodynamic points. So let's go ahead and jump right over to x13, which when P was on the outer circumcircle, was in the circumcircle of my equilaterals, this guy was actually, interestingly enough, a stationary point. Now what happens if P now is nudged outwards? So let's make this guy B1, and we're going to nudge P outwards. Let's see what happens. X13 is no longer anything amenable to easy analysis. So that was really a singularity where this complicated curve shrinks to a point. And then going inwards, again, we have a complicated curve. You can see here that some of these straight lines actually don't exist. This looks like a curve that is piecewise circular. So I have a first circular, maybe hemisphere here. And here I have a second hemisphere. Okay, and it looks like they have these discontinuous jumps, which are here depicted as straight lines, but you can sort of mentally delete them. So that could be interesting for analysis. As P is moved further inwards, let's go ahead and move P inwards. Let's see how this thing degenerates. Okay, okay, so I transition from something that is piecewise curvilinear to something that is a single oval, right? And we had seen this phenomenon before when P is exactly on the in circle. X13 is an oval hanging off of the circumcircle. But now as I move P inwards, I remain an oval, and there's nothing really too interesting here. Okay, how about X14? Let's start X14 on the outer. So recall that X14 in this case was a beautiful circle tangent to the circumcircle at P and of the same radius, right? So what happens when I move P outwards? It loses its simple circularity, and in fact it creates some additional features here that we're not going to go into. Going inwards, also it becomes this complicated, ghostly, sinuous curve. Going in, blah, blah, blah. Okay, so here, this is interesting. Okay, so there's one interesting phenomenon here. So if X14, if P is exactly on the inner circle, and we saw this in the previous video, this guy was not being reported as a conic. Okay, which was strange, right? It looks like a circle, but it's not being reported as a conic. It could be, there could be some numeric error here. We still have to check this. But this guy visually looks like a circle, right? But it's not being detected as such. Now, what this guy is saying is, if I now nudge P inside of the end circle, all of a sudden, I'm reliably detecting this guy not only as a conic, but as a circle. So I would venture to say that that guy, which visually looked like a circle, is not being detected as one, probably because there's some problem in the locus computation. There might be one or two outlier points that are going to infinity, and that's confusing my locus computation. But I would venture to say that since this guy is being detected reliably as a circle, that even when P is right here, x14 is a circle. Of course, if I move P outwards, you can see that there's this sudden transition. This could explain why it's not being detected right here as a circle. But if I say instead of 0.54999, and I just nudge it inwards, 4999, just a tad, all of a sudden this thing becomes a circle. So just by looking at these numbers, I would venture to say that x14 is a circle of radius 0.4 of the circumradius of the system if P is on the incircle and inward. So if you go inward, it continues, and this is very strange, it continues to be a circle as we move inward of bigger and bigger radius, correct? Yes, of bigger and bigger radius. So this is actually a pretty interesting phenomenon right here, that x14 can remain a circle even though P is in the interior of the incircle. Can this phenomenon survive affine transformations? Let's see. So as I apply an affine, looks like x14 is no longer a conic. Not even when it's on the inner, right? Yes, not even when it's on the inner. So it looks like x14 only has a nice harmony precisely if I don't have any finite transformation applied to the system. So the claim here is that x14 is a circle for all P on the incircle or in its interior, or not exterior to the incircle. How about x15? So let's go back to, well, let's leave it right here already. x15 does not look like a conic when P is interior. And as I move P outwards, and I reach to the inner position here, if it allows me to do that. So when P is on the inner position here, it's actually on the incircle, this thing is not a conic. And as I move outwards, looks like it's not allowing me to do this very easily, but remember that when P was exactly on the outer conic, it was a circle. How about when it's actually turned outwards? Then it becomes more complicated, and I expect something similar with x16. x16 is this complicated piecewise circular or conic shape with many sort of discontinuous jumps. But when this guy when P approaches the circumcircle, recall that x16 was a circle tangent to my circumcircle at P. How about when now P goes inside the circumcircle? Let's do that. Okay, it's now no longer anything recognizable. And then when I enter the interior, x16 is this weird kidney-shaped thing that is glued to the circumcircle when P is on the incircle, but then it sort of detaches and goes off to wherever it goes. Not that interesting. Okay, guys, so much for the phenomena now regarding different radii or different distances of P with respect to the center of the system. The next couple of videos, I'm going to switch gears a little bit. I'm going to, instead of looking at cevians, I'm going to look at anti-cevians, and there's many interesting phenomena there. See you then.